Okay, so I'm going to be talking about observing AI applications this evening. I'm specifically talking about OpenLit, which is what's going to be in the demo. But to be perfectly honest, I'm actually going to try and cover it from a bit more of a fundamental perspective so you guys can understand what's different in terms of observing and monitoring an AI agent in production compared to monitoring a traditional web application or something running in Kubernetes pods or anything like that. So we're going to talk about why it's different. We're going to talk about tracing and what kind of additional things you can see using kind of that type of telemetry. And we'll then talk about guardrails and evaluation. So I guess a quick show of hands, who's heard of AI evaluations and know what they are? So we've got 2, 3. So by the end, there's going to be a lot more. And then guardrails, maybe a few more. Okay, so by the end of the night, all the hands are going to be up. So if you've not met me before, my name is Carly. I lead the developer advocate team at Elastic, which is part of DevRel. I've been there just under 4 years, and before that I used to work at Morgan Stanley, loads of different roles, loads of different hats, but one of my main roles was as a front-end engineer working on all sorts of different systems. I'll be around afterwards with the networking if anyone has any questions. We've also got Q&A, but if you think of a question after this or you just want to connect, that QR code's my link tree. Find me where you are because I have all the socials, I collect them like Pokemon, so come find me where it works for you. Right, I'm hoping at a DevOps meeting we all know what observability is. Does anyone not know what observability is and is not needing a reminder? So that's absolutely okay, and that's why we're here to learn, right? So observability is about us being able to collect information about what's happening in our programs and what they're doing. So this is the official definition from Wikipedia, and what you can see is the main things it's talking about is what's happening in a program's execution, what are the internal states that we're seeing, and also if we think about more complex architectures, so maybe we're running multiple services in Kubernetes, then we've got this communication element, and we need to see how each of these individual elements kind of communicate together. And all of these things we can basically see through observability platforms and through telemetry. So here's a kind of really simple example of what we would mean by these types of information. So hopefully we all know what logs are. So those structured error messages that we tend to spit out and think we're never going to look at again until the world implodes. We've then also got the notion of metrics. So that could be things like latency, throughput. It could be, 403 error code counts, things like that. And then we've got a trace. So for anyone who's not familiar, these basically show the pathway of execution through those components like we were talking about before. So here I've got a super simple example where I've got this web application that has a GET request initiated, and off the back of it, it's triggering basically a call to a controller underneath, which is in a Java service, and we are able to see that. So this is your full trace, and each of these have got 3 distinct spans within it. Does that make sense? Cool. So observing AI applications is different because the LLMs we're using fundamentally change the game in some regards. We're used to, very procedural, logical things that should hopefully trigger the same deterministic way every time. LLMs don't function that way. You can put the exact same input into one of these and get a different output. The other thing when we start looking into agentic systems, multi-agent systems, and also MCP is the notion of tool calling makes it complicated as well. We don't make the decision whether the language model is going to call the tool. It makes the decision for us. And we can end up with wacky performance situations, like maybe it's calling the same tool multiple times when one time would have been more sufficient. Or maybe it's not calling particular tools and it's relying on its own data. There's all sorts of different things that make it more difficult to understand what's going on in a production system. And that means that we need to think about observability and the types of telemetry we're collecting a little bit differently. But the other thing we need to think about is that the attack surface from a security standpoint is also slightly different. So who's heard of the OWASP top 10? So for those who are not familiar, OWASP is an organisation focused on security vulnerabilities. And regularly what they tend to do, so the big thing when I was like a new engineer was check out the OS top 10 every year. It didn't really change that much, but sometimes things moved around. And these were basically known as the top attack surfaces and the most common kind of issues and vulnerabilities within applications. But one of the things that's emerged is that they have a dedicated top 10, as you can see up here, just for LLM applications. Because some things are similar. If we think about the notion of injection, we're used to injection from things like cross-site scripting, from SQL injection attacks, but also things like prompt injection, model poisoning, and some of the weaknesses and things around misinformation and vector embeddings. All these things are very specific to these types of AI systems. And we need to obviously therefore rethink our modelling and our observability a little bit more carefully. So that's why I'm showing you how to use OpenLit this evening. So this is an open source project that basically sits on top of OpenTelemetry and generates signal information that we can ingest into an OpenTelemetry compatible backend and then see the results. Just to check, who's familiar with OpenTelemetry? Probably a few, but not all. Yeah, about half of us. So OpenTelemetry is a CNCF incubation stage project with wonderful developers in the community building out SDKs, Kubernetes operators, and all sorts of various tools to basically send standard schema-based signals of the different types of information of what's happening in a system that can then be ingested and monitored into any compatible, what we say, backend, which is basically, an observability tool like ElkStack or Datadog or something like that. Is everyone following me? Nods are good. Cool. This is the example that if the demo gods are nice to me that we're going to see. This is basically my little travel planner example. So what it's got access to 3 different tools that pull in data from different sources. It's got a really fast spinner as well. And you can see that it basically generates an itinerary as well as we go. So hopefully nothing too complicated. This is the architecture for it. So you see that we've got the main agent here. So we're using AI SDK and Next.js, which is then ingesting the necessary prompt. I'm here using OpenAI hosted on Azure. Side note, other models are available. And then what we've got is the option for OpenAI to call 3 individual tools as well. But what you can see behind my head is basically this is the instrumentation we are here. So you've got OpenLit, which is passing the telemetry signals through a proxy and into a collector and then onto a managed endpoint. Cool. So this is where I try and do this with one hand. This is going to be interesting. So we're going to see what the tracing is going to look like. So first things first, we need a prompt. And in true Blue Peter style, here's one I created earlier. So let's go to Amsterdam, see the canals. This is the first prompt that we're going to set. So when I trigger this off, it's going to go off, send off the prompt along with my system prompt to OpenAI. It's actually called the necessary 3 tools here with the various sources. And you can see it's also generated an itinerary live. So all looks to be working. In order to make sure that it's sending the telemetry, we need to utilize OpenLit and the entry point for the application where we're actually using our particular invocation of the model. So if you were using another tool, not AI SDK, basically wherever you're invoking the LLM, that's where this initialization needs to go, so it wraps around it. So what will happen is you can see here, openlit.init is the initialization step. Now for people familiar with OpenTelemetry, some of these things will not look very different, they're very difficult, but you can see here we've got an application name, service name or resource is basically what we're talking about. We've got the environment, because obviously I'm hoping you're doing some form of comparison on production and non-production traffic. We need to specify the OpenTelemetry protocol compatible endpoint that we're sending to. And then I wouldn't recommend this for production, but I've disabled batching because it's a live demo. Obviously, I'd hope you're utilising batching in a production scenario so that you don't overwhelm your backend. Okay, so the types of signals it's going to give us. This is a great time for Elastic to decide that I need to log back in again. Well, we did, maybe we weren't as nice to the demo gods with the offering earlier. That's fine, I've saved tabs, we're all good. Okay, so if I open my demo tabs, here you'll see is the live telemetry that has been captured just now. So here we go. So as you can see, if I expand this out, is this big enough? Can people see that okay? Maybe? Okay, so if I look at some of the types of attributes that I've got on inside my tracing, the first thing you'll see is the notion of the messages. So it's not just like a one prompt and done thing. Normally we're dealing with like multi-conversation, right? So here you can see all of my messages in a big array, so you can see what's actually been sent between the LLM and the user. You can also see other attributes as well, so if I clear that out, you'll see that the model provider information is here. We've also got metrics, so things around the number of tokens, because tokens are basically one of your main elements of figuring out how much this is costing you, because most models are you're paying per token. And you can actually see a breakdown, so if I look for tokens in here you go. You'll see I've got my input, output, and reasoning tokens. So if it's a reasoning model, obviously this would be hopefully greater than 0. And we've got the total element in there as well. One of the other things is, when I talked about the notion of tool callings, is that if it's calling particular functions that you've defined, as I have in my case, you need to be able to see what tools have been called and with what. And that telemetry is also available in here. So you'll see here, this is the definition of all the tools that are available to this particular agent. And it's actually got the notion of the calls here. So you can see that I've got, this is my flights tool, it's been called with the destination Amsterdam and the origin London, and it's also got the weather tool, and then there should be one to the Foreign Commonwealth Office. So it explains the inputs and outputs. So we've got a full idea of what happened within that particular call. One of the other things that we've also got is the tracing. So similar to what we're talking about with vanilla OpenTelemetry, but the bit that's different is that we can see these tool call accesses. So here's the first one. You can see it took 197 milliseconds, and the first one that was called in order was in fact the one to the weather API. So that's the one it went to first. Second one obviously went for the Foreign Commonwealth Office guidance, and then the third one, it made a call to Elasticsearch. So we can not only see what tools were called, but what those calls are actually doing. So if you have a situation where it's getting stuck in loops or it's calling the same tool over and over again, you'll be able to see that within the tracing, which is quite handy. Right. So now we need to talk about evaluations, and I know that quite a few people didn't know what evaluations were, so I'll explain what evaluations are in simple terms. But first I'm going to talk about why. So I guess pop quiz question, who's ever had an LLM generate an answer that was wrong? I'm slightly worried about the people at the back that have never had an answer generated that was wrong. Are you guys fact-checking things? Keep running, keep running. Very worrying indeed. Right, so for those who didn't put their hands up, newsflash, LLMs make things up sometimes. They are not infallible entities, okay? They make them up for all sorts of different reasons. So one can be down to the model itself. They normally have something known as a cutoff date, which is basically they've been trained on data up until a particular date. So if you ask a model with a cutoff date of November 2024, what happened in the football last week, guess what? It doesn't have a clue. And that's one of the things we need to think about, is the context going in. There's also, with particular models, they're normally trained to be a bit more general purpose. But if you go for something a bit more specific that's, got narrower parameters, we have this machine learning construct known as overfitting. And basically it means that that model is going to struggle with the type of task you're trying to give it. We've also got biases in data. So, we of course talk about gender as one key characteristic, but certainly things around socioeconomic status, religion, all sorts of other protected attributes. If we're using agents to make key decisions, if they're picking up biases based on these attributes, that can land us in a bit of hot water, depending on what it's trying to do. But then there's also language ambiguity and catastrophic forgetting, which is code for the model has a massive brain fart and basically forgets massive realms of its training data, which is a real thing. LLMs have brain farts too. So, one of the other things that we need to bear in mind is that as humans, have incentivized these models to make things up, right? Because as you can see from this paper behind my head from last year, the point that they're trying to make across from the researchers at OpenAI is that the evaluation procedures that these models are going through to train them are actually rewarding them guessing stuff and therefore sometimes getting things wrong versus making a mistake, right? So we need to think about these things, and that is what evaluations are for. Evaluations allow us to check things, because at the moment, they're not doing that for us. There was a paper put forward in December of last year, of which this is an expert, again from OpenAI, that talk about this notion of confessions, which is basically this bit at the bottom where the LLM kind of says, okay, I didn't answer these questions, and has to give an honest assessment about how it did. Until we have mechanisms like this or something else, we need to rely on other things. So evaluations allow us to check basically the quality of the output, does it have issues, biases, all these kinds of things. One of the common mechanisms we use for that is an LLM as a judge. And what this is in simple terms is you pass the prompt and the information, and it basically has to go and figure out, did it hallucinate or make things up? Did it have any issues in it? That's what LLM as a judge is in simple terms. Cool. So there's all sorts of different types of evaluations and things that you'd want to check, but the main things that you can see from OpenLit, it captures these three by default. So there's hallucinations, which we've already covered in great detail. It makes things up, things that are wrong, things that contradict what, something later on in the output. Toxicity, so stuff that is threatening or perhaps, attacking or dismissive. Yeah, some of these examples are actually real things that have been spat out, by the way. And there's also biases as well, as we've already covered. All right, so I have a new demo for you. So I'm going to try and trick this LLM to basically read a false evaluation result. Oh, there we go. Okay, there we go. So with this run here, what I've done is basically I've got a mention to the Brandenburg Gate, but I've asked it to plan me a trip to Madrid. So I guess pop quiz question, where is the Brandenburg Gate? Is it in Berlin? You guys have been using LLMs and trusting the answers again, haven't you? Anyone got the right answer? Well, yeah, but it's in Berlin, Brandenburg Gate. It's in London. Are you new here? Anyway, here we go. I say it's in Berlin, but I'm trying to trick it to say it's in Madrid. So I have had, it does depend partially on the model, so thankfully GPT has figured out that it shouldn't be. But what you'll see here is that within my traces, if I go to my evaluations tab, you'll see here that it's figured out that there's a factual inaccuracy on it. So if I expand this, so you can all see towards the back, incorrectly placing Brandenburg Gate Madrid. In order to get this, what you need to do in OpenLit is we basically specify evaluations. So what you've got here is you need to specify the provider, i.e. the model provider that we're going to be using for the evaluations. We need to set collect metrics so that it will send to the backend, and then the API key and URL that we're going to send to, so the model information. And that's how we've ended up with that evaluation telemetry being sent in. And that obviously means that we can try and detect key issues, potentially do alerting, or indeed you can start to do fancy things such as dashboarding. So this is an example here. You can see I've got counts of hallucinations and some other elements in here. All right, so the last thing we need to talk about is guardrails. Now I think of these as like the bumpers of AI, which is basically we've set up particular mechanisms to say, I don't want you to do this, I don't want you to do that. And in these systems that can be quite important because you might want it to stick to particular topics. A good example would be if you're doing a chatbot that's meant to give general advice, maybe with regards to helping a customer with orders and stuff. You don't want it saying embarrassing things. You don't want it, trying to give financial advice. You don't want it spitting out React code for someone who's trying to vibe code something for free. We need to think about these things. Some of the types of guardrails that you can see would be these. So you've got the notion of prompt injection, which is where someone tries various different attack surfaces to either elicit information they shouldn't or get it to do something potentially embarrassing for the organization that owns this thing. So a key one would be impersonation. So a quite common attack surface is actually trying to say that you're a pirate or some form of nefarious kind of morally corrupt character to try and get the LLM to send out information that it shouldn't. You need to make sure it's protected against things like that. We've got the notion as well of trying to get opinions, trying to extract personal information, all of which are big no-nos. We've then got the notion of sensitive topics. So again, maybe don't let your chatbot talk about politics unless you want to land on social media. Talking about mental health can be particularly an issue, which we've seen in the news as well. Anything that's discriminatory, you don't want them spitting that out. And then, as we kind of said before, you might have your own restrictions. Maybe you don't want it giving financial advice. Maybe you don't want it talking about the weather. You know, you can put these own kind of basically tracks in place to say, if it talks about these things, I want to know about it. So for our last demo, I have one more prompt for you. So I don't recommend using this prompt. Please do not use this prompt against a live app. So yes, it's got illegal messaging in it. Please don't do this. But I am going to do this. So into my little travel app, this prompt goes. And hopefully it's going to do the right thing. It is doing the right thing. So it is basically saying, I can't do this for you, which is exactly the answer that we should be getting, which is good. But we still want to be able, in some instances, to be notified of these things. It might be we need to pass some things on to the authorities. It might be that they're trying to do something else nefarious and we need to try and block that user, or we need to check that they're not trying to infiltrate an attack surface. These are all important things that we need to check. So what happens when it triggers a guardrail, if everything's gone well? Oh, the demo's starting to fall apart. So let's look at the last 24 hours. So here is Blue Speaker style, one I did earlier when a trial run. Good thing is trial runs. And you can see here that it's actually picked up the substance use thing. So we would obviously track against that as well. And then again, we would want to be able to see these particular things. So the proportions of threatening issues that are coming through, you'd be able to see on particular reporting, again, compared to the standard stuff like token usage. And you'd probably deal with these data sources in different ways. So for the more nefarious ones, you're probably going to want to alert someone to have a look at it, or maybe pass it on to InfoSec or another relevant team. And for general things around token use, you might have service level objectives and kind of notions of error budgets and all these other things so that you can try and basically optimize your counts. So that's what you would tend to think of. So we've talked about why AI is different to observe, and we've talked about tracing and the importance of tracking tool calls, talked about evaluations, and talked about guardrails as well. If you want to learn more, there is the OpenTelemetry website. There is OpenLit, which is the tool I've used today. There are other alternatives available, so key ones would be OpenLLMetry, which is also sitting on top of OpenTelemetry. You've also got ones like LangTrace. There's also other ones available based on particular cloud providers. So for example, Microsoft have a dedicated evals toolkit that you can use. And then if you want to check out my code, that's the GitHub repo for it there. But it has been a pleasure. I think we've got time for questions, and thank you very much. Yeah.
So OpenAI was then used for the actual application itself, and then you're also using it to then evaluate it. Mm-hmm. Is there any danger, like you'd said, when, where's the Vandenberg gate or whatever, if that gives an incorrect answer, would the judge also think that incorrect answer is correct? Because they're both using the same model.
So there's a lot of different kind of research and kind of elements of this. So there is some trail of thought that you should use a different model, because the same model hypothetically can have a bias towards, favouring its own output, and that's a really common thing. And there's also other types of biases that can be elicited as well. I've just used that example because it's convenient. But you're right, you might want to consider using a different model. You might also want to consider one that's kind of, self-hosted to keep your costs down. And in those particular instances, you should think about what model you want to do the evaluation. But yeah, you're right, it's something you need to consider. Yeah?
Hi Carly, thank you for your talk. Brilliant.
Thank you.
I'm a trainee surgeon working in the NHS. I want to increase the amount of AI that we're using through AI agents, etc., to make the NHS more efficient, reduce wait times, cut out medical errors, all that sort of thing. It's a huge project.
Yeah.
I'm going to need engineers, right? First off, how do I find engineers like yourself, who are very experienced and know what they're doing, when it comes to big corporate entities? And what's the realistic time frame for getting the sort of results that will get buy-in from stakeholders? Over to you.
Wow, that's a big question. Well, I think with regards to the hiring market, I mean, AI is a pretty new thing. I think if you're looking at trying to get experienced engineers, there are some out there, but there's also a lot of engineers that are learning stuff as they go along. And I know that the job market's also pretty sucky right now. I've actually got a friend that's looking at the moment as well. I think you're going to have to certainly consider hiring some more senior kind of expert engineers in that can build this stuff and know about how these capabilities work. But I think you're also going to have to potentially, in order thinking about a more broader workforce plan, you're going to have to invest in juniors as well. That means that you're going to have, junior engineers that maybe don't know enough about this, but have kind of, got the kind of pluck and, are wanting to learn new things. So I think you need to consider, with regards to your development teams, that kind of composition of senior engineers they can learn from and juniors. So you need to think about that in terms of the composition of the roles you're hiring for, in my honest opinion. And then the other thing you'd need to consider is, how are you going to interview them? What kind of mechanisms? So I know it's quite common to have some form of take-home test or something like that, or some kind of coding challenges. You're probably going to need something like that, as well as the ability to validate their experience. So one of the things I do quite commonly when I'm hiring for roles is I look at their external GitHub repositories and see what code they've done themselves, what's the quality, are they writing tests, all these other kind of things. Because you're not just looking at, can these people build AI systems, can they build maintainable, testable, verifiable systems? So you need to look not just at, do they have AI skills, do they have, the skills to maintain the systems? With regards to getting up to speed super quickly, which is obviously you want to show return, when I've worked in other industries, the way we tended to do this is having like a top level set of goals, and then you need to map the deliverables against that. So we normally call them OKRs, but basically some form of measure to say, this is what we're doing, this is what we want to achieve, and then you need to quantify the deliverables against them and try and work in small cycles, regular prototyping, use this evaluation stuff for testing as well as against production, and then that should hopefully help you. But if you want to chat more, come and find me afterwards.
Thank you.
Yes?
Hi. Number one, congrats is probably one of the chats more entertaining that I have seen.
I aim to entertain, thank you.
Very good. So, sovereignty is now, in everyone's lips, and I have not seen any tool of observability that covers that. Do you have any experience?
What was the tool, sorry?
Severity.
Severity.
Severity is like where the data is coming from, who accesses that data from, etc.
Oh, so the notion of kind of like audit and identity. Does this come down to traditional authorization authentication kind of thing?
I think it's come down to the bombing of AWS data centers in the Middle East and being able to isolate data
Yeah.
from geographically, actually.
So,
Detect where it's coming from.
yeah, so I think that's something that's certainly challenging. I know in observability, like one of the things you can do is map out using IP addresses to see where the source of particular calls is coming from, because I know particularly in some like institutions, particularly if you're an SEC kind of filed entity in the States, you need to make sure that you're not you're not dealing with sanctioned countries and things like that. So normally, as part of kind of your observability and security posture, you need to basically be validating where those calls are coming from, and then potentially using like provider technology in order to block the offending addresses and things like that. The other thing you've got to think about is, you remembered obviously data sovereignty. The idea is, where's the data in the first place? And with that, it depends on jurisdiction partially. So for example, some countries, your data can't leave the country. And in that instance, it's looking at cloud providers, where they're actually hosting and where your services are hosted, where's the data going to be stored, and is that therefore meeting the compliance requirements? Because you can't just say, my vendor said it's here, you need to be able to validate it as well. So it's a two-pronged thing. It's not just about the requests coming in, which you can obviously try and detect using IP and those kind of mapping things to identify where they are, but it's also where your data is stored as well. Does that make sense?
Yeah.
Yeah?
In the examples you gave, I noticed there was no direct reference to memory.
Yeah.
Already was in the alternative to the technology organized by Oracle. Memory consistently became an issue with LLMs, especially the episodic and the segmental memory. There was no, the examples you gave never made any direct reference to memory, and that's very, very crucial actually to the way LLMs behave in context.
So I glossed over that because this is an observability talk and not a talk on memory, and we could chat about memory all evening. But one of the things that it is doing, if we skim past everything, so in this on finish call at the end, I'm actually persisting every single message. So I'm making use of a mechanism known as semantic memory, where I'm persisting the particular itinerary message. And then if we scroll back up to the top, it's actually getting a hold of the similar messages, and then the actual messages that are being sent to the LLM is not just the current messages for that session, it's a set that are sent before. So that's kind of a principle of context engineering, is managing the short-term memory within this session, and then the long-term memory would be persisting those itineraries, you know, in a vector database. Some people persist them in file systems, for example, all those kinds of things so that it's accessible. Where memory gets challenging is you can easily bloat your context if you return too much, and that therefore means that you end up with either a context overflow where not the full information is present in the context and you end up with not great results from the LLM, or you can end up with the kind of opposing problem where it's maybe not got the right information and therefore it causes an issue. So with memory, in addition to making sure you find the right data, you've also got to think about pruning and managing what's stored there, as well as where it's stored and what's being returned. And there's a whole, you could do a whole talk just on memory, but that's what you would need to consider. But yes, it has been glossed over in this example. Does that make sense?
Yes. When you made a reference to databases, were you referring to vector stores, vector databases?
Just because this is an example that's utilising a vector store to persist them, it doesn't mean that you have to use a vector store for persisting memory messages. It really depends on what you're storing and how you want to retrieve it. Does that make sense?
That's okay, that's fine. Thank you very much.
No worries.
Awesome.
One more? Yeah.
Very quickly. You briefly touched on agentic things, agents. So platforms like Foundry or Databricks One Agent, can it integrate with that as well? So you can then track your Foundry agents.
So this is Microsoft AI Foundry stuff you're talking about?
Sure, yeah.
So you should be able to use OpenLit with it, but Microsoft do have dedicated tools for evaluations and tracing and things that probably integrate a lot better. So I definitely recommend having a look at those as well, but they're well documented on the Microsoft resource docs, and you should be able to have a look. But they've got an evaluations framework, and I'm pretty sure they've got equivalent things for guardrails, and they also have telemetry integrations for AI as well that work on top of OpenTelemetry, so you're definitely able to do it.
So for Databricks One Agent specifically, because that only released very recently, it's something like that with is then support for that going to be created as well, because they don't have a tracking system unlike Foundry.
I'm not a Microsoft expert, so I'd probably need to follow up on that one to be sure.
Just curious.
Cool, no worries. All right, thanks very much everybody.